Thank you. Thank you very much for inviting me. Just a short overview, what I spent the years on and what is my expertise. I looked at the emissions from a lot of different sources, especially the organic fraction of the particulate matter. And there, especially as just mentioned, are there any compounds which can be used as markers to trace a source in the atmosphere? Why is that important? Well, if you have marker substances, then you can do source apportionment. That means you can figure out at a given site how much might arrive from a different source. So that's the main thrust. But I also was involved in a whole bunch of atmospheric studies from Pittsburgh, Baltimore, South Florida, and Los Angeles. Well, we heard already a couple of times that the air is not the best here in the San Joaquin Valley. And also, when it comes to organic particulates, well, some of the constituents are known to be not very helpful, that it might cause adverse health effects. But then also the organic matter being released into the atmosphere might eventually react on, and also we have atmospheric chemistry generating from the gas phase to the particle phase new organic particles. Well, this is on this slide we see an emission inventory, a rough emission inventory on for a day in 2008. The data are from the California Air Resources Board, and here you have basically different source categories showing the PM10 and the PM2.5 emissions in tons per day. And essentially, I mean, you can see that, for example, just this morning it was mentioned, is cooking a source for pollutants? Well, particulates coming from cooking contribute in the San Joaquin Valley about the same amount in terms of particulates as gasoline-powered vehicles, for example, and that's often the same magnitude in other cities. So cooking is actually important, and I will cover that one. Also, we talked about wood smoke already, so I will talk a little bit what comes of burning wood and biomass. And then I will cover a couple of fugitive dust sources, since they're especially important here in the San Joaquin Valley. This slide we saw already before. I have that in here to basically indicate when you look at the daily average emissions generated from the emission inventory, well, that's not really what we see going throughout the season of a year. Wood is mainly burned in summertime. Photochemistry is very important. Wood is mainly burned in wintertime. Photochemistry is more so important in summertime, and so on. Well, let's have a look at wood burning. Well, EPA publishes this nice little graph actually indicating how efficient different type of burners are. And when I was living in Pasadena, I was living in a house with a nice open fireplace, and depending on how you open the window or the doors, actually it could get cooler. So depending on the heating system you actually have, burning wood, the efficiency can be very lousy. So usually open fireplaces are a great waste in terms of energy conversion, but newer stove designs are much, much more effective, and therefore you also burn less wood and generate less pollution. Well, when it comes to wood or any other biomass, usually they're made of three biopolymers: the cellulose, the hemicellulose, and the lignins, and then some other compounds. And when we look at the cellulose, well, it's made up of these glucose monomers, and when we heat it up, among many other compounds, we also generate the famous levoglucosan, which is a nice tracer for cellulose type material. That means if you burn your jeans, you also will see a signal of levoglucosan. When it comes to the lignins, the lignin polymer is made up of these phenolic type compounds, and when you break them up due to heat and combustion, you get a lot of hydroxy, methoxy, phenolic type compounds, and some of them they are very helpful for us because we can use them to differentiate emissions coming from pine wood, from needle, from softwood, or from deciduous trees. But others indicate that these phenolic type compounds might also have adverse health effects, act as irritants, carcinogens, and might be even teratogenic. When it comes to the hemicellulose, well, we know that they're made up of these 5 and 6 ring sugars, but being burned up, we still speculate a little bit on what we actually generate, and we have a little study ongoing actually looking at the individual compounds being generated when you burn up hemicellulose. Well, when you burn wood and you look at the balance of organics being released to the atmosphere for the particulates and for the volatile hydrocarbons, essentially only a small fraction, maybe 20 to 30% of the organic matter escapes the chimney as particulate matter. The rest is essentially VOCs. What's really important is wood itself as a solid, it doesn't burn, it might glow, but what really burns are the gases being released from the wood while heating up the wood. So here I just want to concentrate not on some markers, rather on polycyclic aromatic hydrocarbons, because some of them are known to be mutagenic or even carcinogenic. And so let's just have a look when you burn wood in a fireplace, what you got. And here I have all sorts of studies sampled together, and the scale, the emission scale in milligrams per kilogram is logarithmic, and so you could ask, well, why are the emissions different for this different type of polycyclic aromatic hydrocarbons shown here? Well, first of all, combustion conditions are always different depending on what burner you use. But wood, for example, is not just wood. The trees, when they grow, even when you just take one tree and you cut it in pieces, the wood itself, the composition of the 3 biopolymers varies. It's similar like to a structure, a building, a bridge, or whatnot, depending on if the tree has to carry more load in a branch or in the stem or whatnot. The composition of these biopolymers will change, and so therefore when people do experiments with 5 grams of wood, it gets a little bit problematic. Here I have just the emissions also for wood stoves, but what I'm driving to is when we overlay them from the fireplace and the wood stove on the log scale, the emissions are fairly similar, or the average emissions. The range can be 2 orders of magnitude depending on how the fireplace or the wood stove is operated. Now, since it was mentioned before already today, residential cooking or cooking in restaurants can be also a source for particulates. And there is a big difference between residential cooking and restaurant cooking. In restaurants, typically people use much higher temperatures for cooking, for frying a steak or hamburger or fish or whatnot than we would usually use at home. So typically in a restaurant, more fumes are generated, but also restaurants typically have an exhaust hood. Often homes don't have an exhaust hood people often just open the window, if at all. So when it comes